Hi folks, Mr. Long here. I'm going to go over the development of the chain rule in reverse, which is called U-substitution. So again, I want you to, let's go back to the chain rule. So in function notation, so if we had the chain rule in function notation, so again, I'm integrating, doing the reverse of the chain rule. It's called integration by substitution. So if I had a function like that, a composition of functions, g of x is inside f, then what's the derivative? Well, the derivative is just inside prime multiplied by the outside prime. Okay, so f represents the outside, g represents the inside. So that's our overall derivative. So let's think about that. Well, what would the reverse of that be? Or the inverse, actually, of that. So what happens if I get an integral that looks like this, where I see that I have an inside derivative being multiplied by a outside derivative? Well, if I see an inside derivative being multiplied by an outside derivative, that's what I notice, then I know my answer has to just be f of g of x plus c, plus the integrating constant c, right? So there's my inside function. So what I have to do is I have to notice, I have to see that there's an inside function and an outside function, right? But in particular, what you really want to notice, you're going to compare, is this g of x, and you want to see that there's a g prime of x. If you can see a g of x and a g prime of x in your integral, you know you're going to use substitution. And sometimes that's hidden, the g of x and g prime of x, so you have to do a bit of work to make it appear. Okay, here's the process. And again, you know that I'm not a step-by-step person. That's not my nature. However, and even in teaching, however, I am going to give you a recipe for this because I think you can get it right every single time. So you're being asked to do an integral, an antiderivative. Okay, so remember that as soon as you see this integral symbol, it means that what's in here is or may have been a rate, okay, a derivative, and you're getting what the original function was. Okay, so and these are, we don't have any limits of integration on these. These are called indefinite integrals or antiderivatives. That means the same thing. Okay, so what was the original function if this is the derivative? So I've got this equation here, okay, and it's telling me that I need to get, so what function was differentiated to get this? So that's the original question. Well, what's the first thing I do? Number one, notice and identify g of x and g prime of x parts inside that entire integral. So what could be g of x and what could be g prime of x? So I always ask myself, I look inside and outside, I look all around and see, is there a potential derivative? So I look at sec squared. What's the derivative for sec squared? Well, I don't actually know. To be honest, I could figure it out if I had a table of integrals, or I could prove it by doing 1 over cos, but that one I'm not so sure about. So let's look here. Okay, what would a derivative of tan x be? Well, we know the derivative of tan x is sec squared. Ah, the derivative of tan x is sec squared. So what I want to do now is, it looks like, and again, I can't be 100% sure, but it looks maybe like that's g, and that's g prime. Okay, so it looks like I have an integral that, or a derivative that was created with the chain rule. If I have a derivative that was created with the chain rule, then to reverse it back to the original function, I use integration by substitution. So that was the first thing I have to do. Okay, what's g and what's g prime? Inside function and inside function prime. So what are the next steps? Okay, the next steps are to let u be the inside function. Okay, let u be the inside function. That's a, 2a. So u in this case is going to be the inside function, which is tan of x plus 1. Okay, that's the inside function. Then I have to determine g prime of x. Okay, g prime of x is du by dx. So let's get that derivative. Du by dx equals, oh, well, what's the derivative of tan x? Sec squared of x. What's the derivative of 1? 0. So things are looking pretty good. It looks like I've probably got a correct analysis here. Now, the next thing I need to do, though, is I need to isolate for dx. So how do I isolate for dx? Well, what I like to do is do the reciprocal of that and the reciprocal of that. Okay, so I'm going to do dx over du is 1 over sec squared x. But I want to isolate for dx. So I'm going to note here, do the reciprocal, because I want to get dx by itself. So now I need to multiply both sides by du. Okay, so get rid of du here, and that's going to be du. 1 over sec squared times du. And that, folks, is what dx is worth. Again, very recipe oriented. All right, so what's next in our recipe? Now we're going to go back to that original integral, which was the integral. Oh, by the way, it was 10 on the here. Any coefficient, take it outside the integral sign. It'll just make your life easier. So put that 10 out here. So you can either have the integral of 10 tan x plus 1 all to the 5th sec squared x, or think of it as 10 integrals of all of that, right? And so 10 integrals of this, or one integral of 10 blah, 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 blah. I think it's easier to do 10 integrals. So 10, and then it's bracket 1 plus, not 1 plus, tan x plus 1, sorry. Tan x plus 1, all to the exponent of 5, times by sec squared x dx. That's the original integral. Now let's go through these steps. So I have to replace g of x with u. Okay, what did we decide on for u? Tan x plus 1. So this thing right here is going to become u. 10 integral u to the 5th. Okay, that whole thing is u. That's our inside function. Then I've still got sec squared x. And then dx I'm replacing. Well, what am I replacing dx with? Dx worked out to be 1 over sec squared du. So it becomes 1 over sec squared x du. Okay, so I'm replacing everywhere where there was an x before, I replace it with a u, with the exception of the g prime part, which doesn't get substituted. But what's the next part in this? Verify that the g prime of x is removed from the integral, so it doesn't look like a chain rule integral anymore. So look at this. I've got sec squared over sec squared. It's gone. So then I can write it in a much simpler form now and just write it as 10 integrals of u to the 5th du. Okay, and that's all I have to do. Now I just integrate that. Well, what's the rule for integration? The integral of x to the n dx is x to the n plus 1 all over n plus 1 plus c. So now I do that integration. So what is the integral of this? 10 integral u to the 5th du. Well, that is 10 integral u to the 5 plus 1. Whoops, I don't need my integral symbol anymore. 10 multiplied by u to the 5 plus 1 all over 5 plus 1 plus c. So I'm going to write that, make it a little bit simpler. So I've got 6 there and I've got 10 there. Well, if I want to reduce that fraction, 10 over 6 is 5/3 u to the 6 plus c. There's something I'm doing in my head right now just to make sure I've done it right. Look at this. That's a 6. So I'm differentiating this right now in my head. 6 times 5 is 30, divided by 3 is 10, which gives me that 10 right there. So I've done that part of it correct. I know that. Okay, so I have that. Now, the very last step is, I wasn't supposed to do an integral with u. I just used u to help me make it simpler. Now what I need to do is to replace u back with what it originally represented in terms of x. Well, what did u represent? Go way, way back. U was worth 10x plus 1. So I go back, and my final answer is going to be 5/3 10x plus 1 all to the 6th plus some constant of integration. Okay? And if I was to differentiate that, I would get my original integral. And that's a good way to check and see if you've done it right. But these 5 steps are the same 5 steps always. Okay? So again, I'll go through that. Please write these down. Notice and identify g of x and g prime of x inside the integral. If you can find that, then you know that you've got a substitution integral. Number 2, let u equal g of x and determine g prime of x, isolate for dx. So get dx by itself, so you can make that substitution. So every time it says replace, it's doing a substitution. Then in the next phase, phase 3 or step 3, what we're doing is taking our integral and writing it in terms of u and making it much simpler to work with. Okay, again, follow those 3 steps there. There's 3 sub-steps, so part 3 has A, B, and C. Number 4, do your integration with respect to u. Finally, put x back in. Okay, put your original function in for u, which is the inside function, put it back in. And that, folks, is your final answer. Okay, so I hope that helped. That's an overview of u substitution. That's the general idea for it. There are a lot of little finicky things as you go through it, but it's noticing what the inside, what g is and what g prime is. If you can do that, you'll be able to get these integrals. Okay, so make sure you have that down. That's really, really, really important. Maybe I'll do one more example here just for you to see it. So if we had this is going to be number 2. Let's do the integral of 6x over square root x squared minus 4. Okay, so we're going to do this. 6x over root x squared minus 4. So first step was, what was our first step? To notice what g and g prime are. So is there something on here that would tell you, so differentiate this part of it, you'd get 6. Well, I don't think that's the original function. But what if I do that? If I differentiate x squared minus 4, I get 2x. So it looks like that maybe has something to do with it. So if I differentiate x squared, I get 6, I get x. So because this 6 here, that'll come out in the wash. But the whole idea is I'm looking for a relationship. When I differentiate x squared, I get an x. Okay, so that probably means this is g, the inside function. This top part is g prime then. Okay, so number 1, we've done that. We've identified the inside function and the inside prime. So what do I start to do? Well, I let u be the inside function, g. So u is going to be x squared minus 4. Actually, the first thing was noticing. This is the second part. Then I do the derivative. Du by dx equals 2x. Next, I isolate dx. So what I do is I do the reciprocal. Dx by du is 1 over 2x. And then I multiply both sides by du. Okay, and that eliminates du on the left, and I've got what dx is equal to. Okay, so now what I do, the third thing is to take this and put it into that original integral. Well, what's the original integral? The original integral is 6x over square root of x squared minus 4 dx. Okay, so now what I need to do is to start doing my substitution. Okay, I have to do my substitution. So, oh, notice I brought the 6 outside the integral too. That's important. So I need to replace x squared minus 4 with u. So I'm going to have 6 integral x over root u. And then I need to replace dx with 1 over 2x multiplied by du. Okay, so now what I should notice here in this third phase is I should notice that I get rid of g prime. Okay, g prime is the x and the x. They're gone. Notice I've got this 1/2 here. So now I have a coefficient of 1/2. I'm multiplying by 1/2. Well, I can multiply that 1/2 by 6 right away. So 1/2 of 6 is 3. So that's going to equal 3. And it's going to be the integral of, now how do I write that with a rational exponent? 1 over root u. Well, root u is u to the 1/2, but it's in the bottom, so that's negative. So it's u to the negative 1/2 du. Okay, and now I need to integrate that. So that's number 3 done. Number 4 is, let's actually integrate that. So again, I'm going to use the power rule of integration. So it's going to equal 3, and it's going to be u to the negative 1/2 plus 1, all divided by negative 1/2 plus 1 plus c. Now, when I do that, now you know normally I would add 2 over 2, but we know negative 1/2 plus 1 is positive 1/2, right? So that's going to equal 3 u to the 1/2 divided by negative 1/2 plus 1 is 1/2 plus some constant c. Now, what I probably should do is, I know that when I divide by a fraction, I multiply by the reciprocal. Well, what's the reciprocal of 1 over 2? It's just 2. So 3 divided by 1/2 is the same thing as 3 times 2. So that's going to equal 6 root u plus c, right? Because u to the 1/2 is root u. Now, the fifth step in all this, that was number 4, is do the integration. The fifth step is to go back to the original function. The original function was u. And let's see here. So the original function is u. U equaled x squared minus 4. That's what I need to replace it back with. So it's going to equal 6 square root x squared minus 4 plus some constant c. And that, folks, is our final answer. So that was the original function. So if you differentiate this, you better get that original integral, which was 3, or no, it wasn't. It was 6x over square root of x squared minus 4 dx. So if you differentiate this, you're going to get that. All right, folks. So I'm going to stop there because that's two examples, and this has been a long enough screencast, but hopefully that will get you started on doing integration by substitution.